Discharge all the remaining ballast. If flow velocity within the pipeline suddenly changes due to valve operation at the start of or during pump operation, the pipeline internal pressure increases momentarily but sharply. This phenomenon is called water hammering. Water hammer can damage the pump casing, valves and pipeline. Shown here is an experiment reproducing the process of how water hammer occurs. The apparatus used is an acrylic pipe fitted with a butterfly valve, through which pressurized water is passed. We observe the behavior of the U-tube attached to the pipe outlet. The acrylic pipe corresponds to the ship's pipeline. The U-tube corresponds to curved sections and pipeline dresser. The section of the acrylic pipe from the valve beyond is of negative internal pressure. In actual ballast operations, there are cases where cleaning with an eductor is carried out in the final stage, which calls for the ballast line pressure to be negative. This equipment simulates such a condition prone to accidents. First, let's look at a case in which the butterfly valve is fully opened suddenly. The U-tube is movable. When pushed by the water force, it moves back and absorbs the impact. With an actual pipeline, such impact cannot be absorbed fully, resulting in damages such as cracks. Damage to the dresser joint is typical. Now we'll review this process using an image simultaneously shot from 3 directions. Next, let's see the case in which the valve is opened slightly and stopped as is. No impact is placed on the U-tube. With the actual pipeline too, it can be understood that there will be no damage to the pipeline if you open the valve slightly and stop it as is. In ballast operations, attention should be paid to valve opening and closing. If a valve is abruptly opened or closed, it causes a sudden change in pressure within the pipeline. As a result, the valve can be damaged. Also, the dresser joint may break due to excessive load on it. The key to avoiding such troubles is to open or close valves slowly. It's also important to reduce the amount of flow in advance so that sudden pressure impact will not be placed on the pipeline. In addition, general points to remember for avoiding water hammer are as follows. Pay attention to the difference in pressures in both ends of the valve. Begin ballast operation with a small capacity and at a slow speed. And fill the ballast line with seawater and confirm that the line has positive pressure. Pressure surge is a factor of possible danger with valve opening and closing. It takes place when the flow velocity suddenly changes inside the pipeline, filled with fast-flowing water, due to abrupt opening or closing, whether remote or manual, of butterfly valves. In the event of a pressure surge, a high-pressure face propagates through the pipeline at a velocity faster than the speed of sound, causing damage to structural parts of the pipeline. So valves must be opened or closed slowly. With butterfly valves, since flow is not proportional to valve opening, remember that a large quantity of water may flow even if the valve opening is small. In short, open valves gradually by inching, stop when slightly open, and observe the state of things for a while. For valve closing, also do it gradually by inching. We can go so far as to say that most of the troubles associated with ballast operations can be avoided unless you open and close valves abruptly. Now we'll conduct a ballast operations simulation, interweaving scenes of actual operations. While introducing the ballast line makeup responding to specific operations, we'll also provide you with a summary of points to remember for ballast operations. To carry out ballast operations, you must fully understand the ballast pump structure and its characteristics, as well as your ship's ballast system. Sticking of a tank's air vent and so forth can cause the tank to expand or shrink, which may damage the hull. Therefore, make it a rule to conduct inspection and maintenance in your daily routine. For ships with cargo holds into which ballast water is loaded, be sure to confirm that their cargo holds are ventilated. To begin with, set all valves at appropriate openings. While in operation, only operate the valves to be used. To avoid wrong valve operation, secure a cap on each of the valves not in use. When opening or closing valves, make sure to pay attention to the pertinent pressure gauges. Also check the pertinent level gauges from time to time. When carrying out any task, never fail to answer back, check, execute, and report. Now we begin filling ballast water by gravity. Put the valve line up in the proper order to bypass the ballast pump. To the extent possible, conduct ballast water filling into an empty main ballast pipe, either via an opening control valve or from the lower pressure tank. When the main pipe internal pressure is negative, inch open the pipe slightly and observe the state of things for a while, then fill ballast water slowly. After ballast filling by gravity is over, let's now proceed to filling by means of ballast pump. Before starting the ballast pump, completely close the discharge valve. Centrifugal pumps are commonly used as ballast pumps. Start the pump with its discharge valve fully closed to avoid an overload at the start of the pump and to minimize surge pressure. Before starting the ballast pump, attend to the following. Communicate closely with the engine crew to avoid any accident due to lack of communication. Confirm that the power supply is switched off. Purge air. Confirm that there is no abnormality with the pump's rotary shaft. Confirm that the suction valve is open and the delivery valve is fully closed. Just before starting the pump, check the procedures again, following the order of operation, abiding by the pipeline layout diagram. Start the ballast pump. After the pump has been started, check the ballast pump electric current value, discharge pressure, and suction pressure. When changing ballast tanks for filling, Open the tank suction valve to be filled next, then close the suction valve attached to the ballast tank that has completed filling. Filling of all tanks has been completed. Stop the pumps by closing the ballast pump discharge valves and then close the tank's valves. Next, let's see the steps for ballast water discharge by gravity. Operate valves to put the line up in the proper order, bypassing the ballast pump. Ballast water discharge by gravity begins as the tank's valves are opened. Next, we'll proceed to ballast water discharge by ballast pump. The ballast pump starting procedures are the same as for filling. Make sure to conduct air purging from the pump and confirm the state of valves and gauges. Watch water level, since cavitation occurs as the level drops, which causes the waterhead pressure from the pump suction valves to decline. As the water level drops further to approach the tank bottom, now exercise precautions against air drawing. Watch the gauge carefully and readily respond to the risk of air drawing. When ballast water discharge for all pumps has been completed, stop the pumps by closing the ballast pump discharge valves. Then close the tank suction valves, completing the steps for discharge by ballast pump. Officers and crew responsible for ballast operations must fully understand their ballast pump characteristics, ballast tanks and lines, valve arrangement, and other facilities. Especially, they must attend to the following while in operation. Keep watch on pressures acting on pertinent sections. Understand the pump's principle and avoid load-placing operations, such as cavitation and air drawing. And understand valve characteristics and avoid water hammer and pressure surge due to abrupt valve operation. Keeping an eye on and